can minimize and everything.
Basically what this is.
Alright everybody, so we're going to get started. For those of you guys who don't know me, I think just about everybody here does, but I'm Andy, president of Digital Friends Club. That's Brandon. Brandon, say hi. Hi. Brandon's VP. Jonathan back there's public relations. And Steve's our treasurer, tech guy. Also the person who is getting us set up with live streams, and it'll also be up right at the Justin TV afterwards. Okay, yeah, so then there'll be a video up on Justin TV of this meeting afterwards. So today we're going to talk about network forensics, and more specifically packet analysis using Wireshark, and later how to do network forensics using a super awesome, powerful tool that's going to make life super easy if you ever have to do network forensics. There's Dr. Montante, our advisor.
Stuff to go over, you guys.
Okay.
Ledger of dust and stuff from last semester.
All right. Awesome. Thank you. It's very cold. It is. It's super cold. Okay, so before we start, I'm just gonna show you guys where I'm getting this specific example that I'm showing you guys, because it's really awesome, because the site has tons of network forensics cases. So it's called forensicscontest.com. Yep. And it's all network forensics cases. So if you just go to puzzles, and then you can see all of the puzzles that they have. There's 9 puzzles. We're gonna be working with Ann Skips Bail, kind of showing you guys how to do some packet analysis on that specific one. But afterwards, feel free, and I would encourage you guys to delve into this a little bit more, because they're really good and they have the answers. So you can always check your answers. There's questions, and then of course answers. So that's nice. So you can always double check your work. Okay, so on the T drive, in the DSC Club folder, there's Wireshark Portable. So if you can copy this entire folder actually and put it on your D drive. And then we're just going to install Wireshark. So just double click it, go through it, install. Apparently that's invalid. Browse. No, don't worry about it. It's okay. So you might have to pick a legitimate path, but anything will really work. C drive, D drive. I put mine in my D drive in the folder that we already, that I just transferred it into. So then once that's installed, you'll have a folder called Wireshark Portable. Double click that, and then double click wiresharkportable.exe. Next. Agree. It's going to ask about when PCAP. Go ahead and install that, and then finish. Then you should have this screen right here. This is just kind of basic interface for Wireshark. You can capture traffic, and then using Wireshark, analyze that traffic that you've captured. It's a very powerful tool, and it's free, so that's nice too. Is everybody here? We're all here? Any problems with installing? Yep, no problem. Everybody else is good? Yes? Okay. Where did I what? The destination folder. I made mine in the D drive. So I did D drive and then DSC and then just put in the DSC club. And you can install right into that folder that you copied over to the D drive. Okay. So moving on, just there's a button up here that says open a capture file. That's what we're going to do. And then go to the D drive. Data, there it is. Then DSC club, and then open up the PCAP file, evidence packet analysis PCAP. That's the one we're going to open. And then once it opens, I like to kind of spread these panes out a little bit. That way they're easier to see. Yeah, so that folder that you copied over from the T drive, in there is a PCAP file. So now it should be on your D drive because we copied that folder over. Open that PCAP file. Does anybody know what PCAP stands for? Packet capture. Yep. It's a pretty standard file extension for network traffic. So anything that's network traffic is usually a PCAP file. So are we all here? No? You guys are good? It's okay. Do you need help?
Yes.
Landon, you think you can? Over there. Okay, so the case with this particular packet capture was this hypothetical person undercover. It's punny. Is she was caught for a crime for transferring this secret recipe from her company to a bad person, which turns out to be her love, kind of like a Bonnie and Clyde scenario. And she got caught, and now she skipped bail, so now she's off and running, and we're trying to figure out what's going on with her. So there's a couple of questions like what's Anne's email address, her email password, her secret lover's email address, kind of basic questions that we would want to ask ourselves while we're doing network analysis. So the information they gave us in this particular case was that Anne's laptop has a MAC address, and that MAC address is 002174D4F8E. And we're going to be looking for communication, specifically communication protocols in this packet capture. So just to start off, we're going to do like a kind of a high-level analysis to see what we have in this particular packet capture. So click on statistics at the top, and then do protocol hierarchy. And you can maximize that. So this kind of shows what protocols are in use in this packet, in this network traffic. So all of it is IP version 4, which makes sense because you can either have IPv4 or IPv6, and most common is IPv4. So that's what all of the packets fall under that category. But under there, the important ones that we're looking at are Bootstrap protocol, which is a protocol in use when you have like DHCP traffic. And does anybody know what DHCP is? What's DHCP? Yeah, exactly. Do you know what that does?
It changes IP address.
Yeah, it manages IP address, exactly. And that's the type of thing that can be used during different other communication protocols. So with that, there's also DNS, domain name service. Down here we also have some SMTP traffic and some IMAP traffic. All of those are used during like communication, so basically mail stuff, mail exchanges is when we see a lot of those. So this kind of gives us a broad idea of what we're looking at. So let's exit out of that. And then we're going to run a quick filter. So run eth.adr, so Ethernet address, equals 00 21 70 4D 4F AE, and then put and boot P. So this is saying let's filter by Ethernet address, basically the MAC address, that MAC address, and then the protocol boot P. So DHCP traffic is what we're looking at right now. Yeah. Yeah. Hold on. Let me see if I can pull up the magnifier. Okay. Is that better? Okay. So type in that. And remember that MAC address is the MAC address that's associated with Anne's laptop. Okay, so then after you got that in, press enter. So this is going to give us 4 packets that are DHCP packets. And the idea is that when we're doing this, we're about to correlate Anne's laptop with her IP address. So, and obviously knowing her IP address in the network capture is very important because she's actually the person that we're looking for. So we need to know what her actual IP address is. So looking at this, there's one packet in particular that's interesting. This DHCP acknowledge packet is where her IP address is given. So for more information on that, if you go down to Bootstrap Protocol, you see more information that's actually super important. So things like DHCP server identifier gives that IP address lease time. So 1 hour. This means that for 1 hour, she's able to have this IP address. Renewal time, so 30 minutes. So after 30 minutes, if she still is on the network with this IP address, it'll renew it for another hour. So it kind of gives us a little bit of a timeline thing. More importantly, though, client fully qualified domain name. Client name, look at that. It says andlaptop.example.com. So now we definitely can say that this IP address is Anne's laptop. So now we've got a little bit of a correlation. Now we know who she is on the network, and now we're ready to look for the next stuff that we want to learn. So just like in normal forensics, things that we can do is search things. That's something we do a lot. So we're just going to do a quick, easy search. We're going to go to Edit, Find Packet, and then we're going to change this to string, and we're going to search undercover. That's her name, so that's a pretty self-explanatory search term. It makes sense to search that. It's her name. We're going to search in packet list, so keep that the same, and then just click Find. Oh, I forgot. Clear this first. We want to get back to the actual packet. So clear the filter, in case you didn't do that. Otherwise, you won't find anything. So find packet, undercover, find. Okay, so is everybody with me? We're good? Okay. Any questions so far? All right, fantastic. So here's some interesting things. So we have at this packet at 1590, a packet that has undercover an email address, sneakygeeky@aol.com, and a subject. It looks kind of like an email. Is what that looks like, and that's actually one of the questions we were looking for. What's Anne's email address? That's important for us to know. We can continue searching through what other packets have undercover. So, just keyboard shortcut, you can do Control-N, or you can do Edit, Find Next. Control-N is a lot easier to do. So there's another packet, another request from undercover, and then Control-N again. Notice that the IP addresses are a little bit different now. So you have Anne's IP address, .30.108. By the way, those of you who are in Enterprise or any Intro to Networking class, 192.168 is what class? Class what? Any idea? Nobody has an idea. Yeah, Class C. Okay. Alright. Okay, continue to do Control-N. Control-N. There's another IP. There's Anne talking to a different IP address, 64.1.2.168.4. Another different email, subject, launch next week. Control-N again. Back to that other one. Control-N again. We're back to a different one. So so what we're looking at now is we have get back to the packet number 1590. So we're looking at 3 packets with the 64 IP address, and on that IP address you're looking at if you look at in here in the packet details, there's a destination port, and that destination port is 587. 587 port, TCP port 587 is commonly used for SMTP traffic, which is a mail transfer protocol, a simple mail transfer protocol, Kevin. Which makes sense. This looks like an email. So now we not only we have something that looks like an email, we have a port that's going to submission. By the way, submission 587, it literally, that's TCP 587 is for submission of email. So this is more and more proving that this is an email packet, and thus important for us. And then we have 4 packets at that 205.188 IP address, and that's over TCP 143, and that's consistent with the IMAP service, which is also used for mail, but retrieving mail rather than submitting mail. So lots and lots of mail things for us. This is super important. So on the first SMTP stream, right click. So you should be on packet number 1590. Right click on it and click follow TCP stream. This is one of Wireshark's most powerful abilities, I would say, because it allows you to, it basically extracts all like layer 7 information and puts it all in one nice area for you so you can look at. So let's just take a look at this TCP stream. By the way, the blue text and the red text, that designates between like source and destination. So the red text would be things that are coming from Anne, and then the blue stuff would be coming from that other IP destination. So in this case, this kind of looks like it's an AOL server, actually. So we look at this AOL, a DNS. It might be an AOL DNS server, or it could be this. This might be the actual name of the AOL server. Other information, this login. Login is plain. So that means that it's not encrypted. So if we look over here, we have auth login, then we have some random character, then we have red, which is what we know is from Ann, some more random characters, blue from the ALL server, red from Ann, and then you have authentication successful. So if you were just looking at these four lines right here, what might you think this first blue one is? 334 VXN. This is coming from the AOL server. Connection. Think about this part right here. Authentication successful. Yeah. Close. Very super close. So this is actually the field username, and then the red one would be Ann's username. This one is password. The red one would be Ann's password. So just for fun, let's actually it's not really cracking because it's not encrypted, so we don't actually have to crack it. But we're gonna it's encoded in base 64, so we're gonna decode that. So just go to Google. And then type in base 64 decoder. Mine will eventually work. Just
Can you just copy it from the B64?
Yeah, we're not using that one yet. That's for later. You'll see. Base 64 decoder. This is just so we can decode a string. So I just clicked the second one. It's the one I'm using. Let's grab the second blue one. Oh. And copy and paste that in there. Click decode. There it is. Password. Password colon. Go with the red one. This is Ann, by the way. Her password. Control C. Paste it in. Decode. There's her password. This is her password for her AOL. It says super secret. It's pretty cool. Nobody thinks that's pretty cool? One person? Alright. Two people think it's super cool. Come on, this is like super geeky stuff. How is this not cool for you guys? You kidding? Come on. It's awesome. Alright. So that's the idea. This is encoded in base 64. Password stuff. So we look down here, this red stuff. Here's the email. This is an actual email from Ann Dirkcover. She says, "Hey, I need a favor." Sounds crazy. And then down here, here's the actual message. "Hey, can you hook me up quick with that fake passport you were talking about?" So there's an email. And not only that, we also know who it went to. Another cleverly named person. Interoptic. Yeah. So that's the basics of that one. So let's exit out of that one. That's important. That sounds good. Let's continue down here. So Control N again. And we're going to skip that one. Control N again. Oh, Control N. Oh, wait. So I always forget this. You got to clear this TCP stream and go back to the actual capture. Okay. Did I lose anybody there? Make sure you clear your TCP stream so there's nothing up in the filter there. You're back to the actual one. So once you're there, Control N. We can take a quick look at this one, 1615. Right click, follow TCP stream. It's basically the same thing we're looking at. Same idea. That's actually the same email, but it's on a different. This is a different IP address, and not to mention here, there's the password right there, super secret. Yeah, that's the reason this is a little bit different is because that's IMAP. This is the IMAP protocol, which is once again for receiving emails. Yep, receiving emails. So once again, clear that. Control N. Control N again. We're gonna keep going. There's another one. Lunch next week. Okay, let's check that out. What's going on there? Follow TCP stream. Again. Let's see what we got. There's the authentication again. Successful. Receive. This is a different person. Dark tangent. I think that's a math joke. I don't know. Anybody know math things? Tangents like circles and stuff, right, Jonathan? Okay. Yeah. So so she says, "Sorry, I can't do lunch next week. After all, heading out of town another time." So yeah, Dark Tangent just got friend zoned. It looks like. Yeah, it sucks to be him. So clear that. It's another email. Control N. We're gonna go down again. Here's something different. Rendezvous. Let's right click. Oh, lost it. Let's right click on that one. I almost said it wrong again. It's like Rendezvous. Alright, so here's something different. Mr. Secret. Now we got somebody different here. That sounds interesting. Strangely enough, I bet this is her lover. That sounds good. So let's look at some of the important things in this one. Hi, sweetheart. Bring your fake passport and bathing suit. Address is attached. Love, Ann. Yeah, this is definitely her secret lover. I think we found it. So now we know who she's talking to. The guy's email address, his IP address. This would. Oh no, don't listen to me. That's not true. We don't know his IP address. We know the IP address of the AOL server. Also, though, what's this junk here? What the heck is that? Anybody have any idea what that might be? It's an attachment. How do we know that? Because down here, it says attachment. And we know the file name. Secret rendezvous.docx. And why is it looking crazy? Because it's base64 encoded, which we can look at right here. It says content transfer encoding, base64. Okay, so but I bet that's important. We probably should try to figure out what that file is, right? All right, so let's do that. Start at the top here where it says UE, and just copy this whole thing. It's not too long, so you can kind of copy that whole thing. Almost done. Alright, so you should end with an equal sign. So I'm going to right click, copy, and I'm going to open up HXD. HXD is a nice hex editor for any of you guys who don't know. I'm sure you guys do, you're all forensics people. So just make a new file, and then you're not going to be able to put it in this area. You're going to have to go into the right side where you put the metadata. So right click, paste insert. Okay. And we're going to save this. We're going to put it on the desktop. Call it Secret Rendezvous because we know the name of it already. .docx. Actually, I'm going to have to call mine 1 just for fun. Save. Alright, so save it. You can close out of HXD. Not going to need it. Minimize Wireshark. So on your desktop, you should have Secret Rendezvous somewhere. There it is, Secret Rendezvous. Try opening it. See what happens. Nothing. It says, we are sorry we can't open Secret Rendezvous 1. We have a problem with this content. Okay. It's a good thing that we're super awesome network forensics people, and we know how to get past that. So, back in the DFC Club folder, there is a file b64util.7zip. Right click on that, 7zip, and then I do extract to b64util backslash, so that way it'll make a folder rather than just a messy list of files. And then I like to, just for the easiness of it, copy that secret rendezvous file and paste it into b64util, which I see I did that. Don't cheat. Delete all. Delete the 2 secret rendezvous files in there. And paste yours in there. Yeah.
After you copied all that big block,
Yeah.
how did you put it in
Really?
HXD?
Okay. HXD. So there's a new file button right here. Click the new file button. You have to come over here to this side. Right click. Paste insert. You have to. Got it? All right. Okay. So now we're going to open up a command prompt. You're going to want to change to the D drive. So D:.
Oh yeah, okay. Mine's on the drive.
Yeah. Yeah, so if yours is in the D drive, you're going to want to go to the D drive. And we're going to do some of our fun 117 command prompt commands. Change directory to DFC. Change directory to DFC club. Change directory to base 64 util. Do it one more time. Base 64 util. Alright. Now if you do a dir, you should see your secret rendezvous file and all of the base 64 decoders. Everybody see that? Yes? Let's all make awkward eye contact for truth since nobody raises their hand. Thank you, Mike, for your head bob. Alright. Everybody's good? You're not good. You are not good? Landon, can you help her?
Sure.
In the back. Next to Chris Grube. What an awkward guy. Okay. Moving on, we're going to decode this file so that way we can open it. So using DEC B64, so decode 64.exe. Then the next thing you need is secret rendezvous to put in your file. You can start typing like the first 3 letters and then tab over, and it'll autocomplete it. Once you got that in, press enter. A new file will be made. It's going to be called docx.out, so like output file. You can get rid of that. Take out the .out, and then say yes to the changing extension, and it's going to freak out because you already have one named that. It's okay. Change it to 2. No problem. Once you do that, double click and open it up, and it should work. Did it work for everybody? Yes? So where are they going?
Mexico.
Yeah, they're going to Mexico. Look at that. Meet me at the fountain at the rendezvous point. Address below. She's bringing all the cash. Is that not exciting for everybody? We just carved out a file that was encoded in base 64 from network traffic. Mind blown.
This is real stuff.
This is real stuff. That's exactly right. Real live stuff. Take this to your future employers and be like, hey, look what I did. I'm just kidding. Don't do that. They'll probably laugh at you. But seriously, though, you actually might do this stuff. This is awesome. I don't know what else to see. Carve out attachment. Alright, so once we got this, there's obviously more forensic stuff that we would do, such as hashing the file. Can anybody give me an easy way that we could hash this file? What could you do using tools that we already have? Yeah. FTK Imager, that's right. Open this up in FTK Imager and you can hash this file. You can do it if you want, but you don't have to. But what if we wanted to get information about the actual picture that's in that in this document? So, oh, that's probably not the one I wanted. That's the one I wanted. So back to this picture. What if we wanted this picture? What if we wanted to extract this picture and get all of the metadata associated with it? How would we do that? And it's not the obvious answer of just right-clicking and copying it and pasting it. How could we do that? Any ideas? Nobody has an idea. What? Copy special. Close. So the way to think about this, what is the header of a docx file? What?
DLC file.
A docx file. That's 2003. So after 2000,
Yeah, alright.
after 2007. PK. That's right. What's PK is the same zip is the same file type for what? Zip file. Yeah. So let's change this to zip file. Let's extract it. 7-zip, extract to that folder. Okay. So then now in here, and it's not in that folder obviously. Media. Yeah, so in Word, Media, image1.png. There's our file. There's the actual image that's in the Word document. Oh, don't rename it. And maybe, if we're lucky, there's some metadata about it. And we're not. There's nothing super important, but there might be. So theoretically, this is how you would do something like this if you needed to find information about the actual picture itself that's in it. Okay. So that's kind of like the deeper analysis of network, of doing some packet analysis using Wireshark. Now I'm gonna blow everyone's mind with the most amazing tool I've ever seen in my life. Network Miner. Hold your applause. You're gonna all not die, but it's pretty amazing. Okay, so back to DFC. DFC Club. There's a zip file in there called Network Miner. Right click, 7-zip, extract to Network Miner. By the way, does anybody have any questions before we go into the Network Miner? No questions. 0 questions. Yeah, what's up?
To begin with, you just type in the MAC address.
Yeah.
How would you get that?
How did I get that MAC address? Well, the MAC address was actually given to us from this, in this case. However, if it wasn't given to us, there are ways to get it otherwise. So look at one of the packets that has and or covers IP address. So 192.168.30.108. Look at Ethernet 2. Check out what we're looking at right there. By the way, what kind of computer does she have? A Dell. There's her IP address. Or a MAC address. Yeah, what's up?
Let's specify the air package.
That packet is...
Electric packet. Go to.
Yeah. What's up?
We're not specify the actually.
Okay.
Okay.
Landon, is everything alright? Yeah? Okay. Alright. So, back to Network Miner. So once you got that extracted, Network Miner, there's a purple little icon, networkminer.exe, run that. You get this kind of blah-looking interface, nothing special really. I'm going to drag it over to the side, just to make room. Go back to DFC Club, back to the evidence packet analysis.pcap, and prepare for magic. Here it comes. Drag and drop, evidence PCAP, drag it right into Network Miner, and just sit back and relax. And it's going to do everything for you. Look at that. Everything that I just showed you is done instantly with Network Miner. So, first of all, that AOL server, now we know that it's a Linux server. I'm not even sure where they got that from, but apparently you can find that.
Do you not remember from networking?
Cisco, what?
It's got a different set, like when it's pinged and it's the end of the message replies, the way it replies with the dead space. It's got a different code set that it sends back depending on what operating system it has.
Okay.
I don't know, Linux or
That does sound kind of familiar, but yeah, that's actually good. So yeah, there's all of those things going on. All of the IP addresses that are in use in this packet capture. And then there's information about these things that you can find. MAC addresses. Down here, we look at Anne's laptop. There's Anne's laptop, Windows. There's her IP. There's her MAC address. There's Dell, her host name and laptop, OS, OpenTCP ports, the packets that she had, incoming and outgoing sessions, tons of information about Anne's computer. So that's just the host. That's great. We got that down. So then it has a kind of a ugly interface for frames. You could go frame by frame and look at each one, and each one will have, the kind of information that you would find in Wireshark. But in Wireshark, I think it's a little bit better. But here's where I think this thing shines. So if you click on the Files tab, for one, there's all the files that can be found within this packet capture. More amazingly, scroll down to SMTP. I like to spread this out a little bit. What do you notice at the bottom? File name. What's that very last one? Secret Rendezvous. Double click or right click, open file. Don't even have to do base64 decoding. It does it for you. Boom, there it is. And I promise you, if you did hash it, if you hashed it before with FTK Imager and you hashed that file, you'll get the same hash. It's pretty awesome. Look at images. So there's all the images that could be found within that packet capture. And you could find the same thing in Wireshark. So you go back to Wireshark. You could do a file, export objects, HTTP, and you would find those same objects. There they are. And you could save them all, but it's not as nice as this. This is super nice. As if it doesn't get better. Boom. Now here's all the emails. Look at that. Need a favor, lunch next week, rendezvous. They're all there. Subjects, dates and times, all the things. The only thing that I found that I didn't like is that it's not necessarily easy to tell that there's an attachment like that secret. If you were using Network Miner, I don't know if you would know secret rendezvous was attached to this email. That was a little bit strange, so keep in mind there's things to know about your tools, but it's still pretty good. Credentials, check out the password and username and password. Super secret, sneaky geeky, all there. Didn't have to do base 64 decoding. How nice is that? Nobody thinks that's nice.
Fantastic.
Well, enjoy your network forensics careers. Then there's the sessions, DNS records are all there, parameters, keywords. I tried, maybe you guys can try, but I tried running keyword searches in there and I didn't get anything to work. I don't know if you guys can, but then there's clear text, so there's just random stuff that can be found. And then some anomalies, so these are some like server errors. But essentially you're able to do almost everything using Network Miner quicker, more efficiently, I think. It's not quite as down and dirty, but it's pretty cool. It's maybe not a bad idea to use them together, Wireshark and Network Miner, but it's pretty good, I would say. It also gives you, on the right side, the case panel, evidence, the file name, and the MD5 for that evidence. That's nice. Also, Network Miner can be used as like a packet capture program as well. You can select a network adapter at the top and actually capture packets using Network Miner. So that's pretty cool. And then use Network Miner to analyze it all. Any questions? Any questions at all? Alright, well, there's no questions. That's all I got for you guys. You guys come back next week. Thank you. Thank you. Next week, hopefully, one of my other co-people will be doing a presentation, possibly Kevin Schroll. If not, one of my other co-geniuses. Landon. We want Landon, you said. Okay. Landon's going to present on theoretical programming next week.
Pay attention. Network reminder on like your own.
Could you? Yeah, you can. Yeah,
Okay.
take it. Yeah, definitely take it. And if you can't, you can download it.
Didn't know if it was copyrighted.
No, oh no, it's a free tool.
I have no idea.
You wanna do your magic here?
Just act well.
There was not. Yeah, we just kind of just go.
Cool, congratulations.